Hello everyone. In today's lecture we will explore some dataset in R. So we will begin to create a data frame called state. Contain the first column is the state name. The second column is the state region. And the third column is another data frame containing some information about the 50 states in America. So we can explore this dataset by the function hit. So it show me the first 6 rows in my dataset. And you'll see here it contains some information about the state name, each row corresponding to a unique state name, the state region, the population, the income, the illiteracy, the life expectation, the murder rate, and so on. We can further explore this set with the function str for structure. And so it tells me that it's a data frame of 50 observation or 50 rows and 10 variables or 10 columns. And of course you can see that there is some continuous variables or numeric variables as you see here, and then categorical variable or factors as you see here. So we'll start to plot some of these variables. We will start with plotting continuous variable like the state population. So we'll type function histogram hist to the state population. So it shows me the distribution of the population in these states, and of course you can see here that the distribution is highly right skewed. So there is some outliers in these sites, and in the small variables there is higher frequency of population in the small variables, in the small values. So then we can further modify this plot by using the breaks argument and increase it from 5 breaks to 10 breaks. So you will see here that the distribution is slightly different due to 10 bins or 10 breaks in this dataset. Of course I can increase that to 10 breaks, and you will see that this is the distribution with 100 breaks. Of course I can add to this plot, and this is a general formula for any plot in R. You can add an x-axis label by the function xlab, and we call it population or state population, and the y-lab or the y-axis lab for the frequency, and the main title for my plot by the function main, and we will call it a histogram of population or of state population in 1973, because this dataset was collected in this year. The second plot we can use with continuous variables is the box plot. So the box plot state for population, and you see here on the right hand side by zooming that this distribution is also highly skewed to the right with some outliers in the larger values and a median around 2,500. To explore categorical variables like the region, we can plot it, and for the state region, so R by default will plot it as a bar plot, and the height of each bar corresponding to the values of the rows contained within that plot, within that bar. We can further explore this variable by the table function state population or state region, and you can see here that there is 9 rows or 9 states in the northeast region, 16 rows or 16 states in south region, 12 rows or 12 states in the north central region, and 13 rows or 13 states in the west region. And of course you can compare this to your plot, and they coincide with each other. We can further, so here we covered how to explore single variable. We can further explore the relation between two variables. So we'll begin with the relation between one categorical variable and one continuous variable. We can use the box plot to plot the distribution of different variables for each category. So we will plot the state region on the x-axis, and this is the category variable, and the state population in the y-axis, and this is the continuous variable. And by default, R will produce for me a box plot for the northeast population, a box plot for the south population, a box plot for the north central population, and a box plot for the west population. And of course, we can further explore this dataset by adding a line by the function upline, and I like this upline to represent the mean of population across all states by using h corresponding to horizontal. So I want a horizontal line. Oh, there is an error because I must define the population, which is the column in the state data frame. This is population, yes, and that is works. So you can see here by the zooming function that almost the north central region have half of its population above the mean. and the west region is the least populated region across these states because the distribution of each population all is below the mean line. We can order these box plot to represent how median differ from each region and order that so we can really figure out the information from this plot. So we will reorder the state region, reorder the state region according to state population using the function median, which is the center line in the box plot, and then plot our figure again, and you can see here that it has plotted the box plot, or it has ordered the box plot according to the median in each box plot. So the lowest median for the population is in the west, then followed by the northeast, then south, then the north center. We can also explore the relation between two continuous variables like the state murder or state population and the state murder. You can see here that it has plotted the state population and state murder, and you can see here that as the population increases gradually, the murder rate will increase. And of course, I can also plot a regression line on this plot by using the applying function, and then LM for linear model, then the state murder, and as state murder is a dependent variable and the state population as an independent variable, and it has plot a linear regression, a regression line in this plot. And of course, I can add an x-axis label call it the state population, and the y-axis label for the state murder, and a main title for my plot. Scatter plot of murder rate versus the state population. And of course, I can plot the regression line again, and you can see here I have plot a nice plot for the relation between the state population and the state murder rate. I can further export this plot by saving it as an image or saving it as a PDF. Thank you.